Dipole antennas can be made physically shorter than the usual half-wave dipole antenna by adding loading coils. It is useful for single band operation with narrow bandwidth. Of course, it is a trade-off between performance and fitting a dipole into a shorter available space. The loading coils have resistive and reactive components of impedance, which can cause loss of RF power in the form of heat. Though this may not be critical while transmitting, loss of received signal power may mean that weak signals may be totally lost. For better efficiency, the loading coil should be nearer the far ends of the shortened dipole, but that would need a larger inductance, which may be technically difficult to implement. Thinner wires for the loading coil would mean more resistive loss of signal. Coils wound on plastic formers are inferior to those wound on glass or ceramic in terms of loss of power. An ideal loading coil would be an air-wound one without any former, which is practically difficult to implement. Physically shorter antennas with respect to the wavelength will need larger inductance for the coils. Inductance required depends on the total length of the antenna, distance from the center to the loading coil, diameter of the radiating wire elements, and the required operating frequency. Ideal coil is one which is made of solid copper and having a length equal to its diameter. Ideal way to check the inductance of a coil which you make is using an LC meter or LCR meter. LC meter means inductance capacitance meter. LCR meter is inductance, capacitance and resistance meter. These are available in the market and you can measure the inductance of the coil. LCR meter will also give you the resistance of the coil. And the inductance can be used in the formula for the dipole calculator to find out the lengths on either side required for making the loaded coil dipole antennas. Another option is to calculate the inductance. From the same site you have a formula L is equal to radius squared into turn squared divided by 9 radius plus 10 length. Radius means radius of the coil which you are making. Length is the physical length which the turns cover in total. Here you can see 68 turns over 11 cm span on 1.5 inch former. When I used the online calculator, I got an inductance of 52 microhenries.